Hey guys, happy 4th of July. Or maybe it isn't the 4th of July when you're watching this, I don't know. Anyway, this year is the 250th anniversary of America. Fun fact, a 250th anniversary is called a semi-quincentennial, meaning half of 500 years. It's also called a sesquicentennial, meaning 2.500 years, because Latin has a word for 2.5, but of course English doesn't. Anyway, let's get to the main topic of the video. What color covers the most area on the American flag? This has been solved before, but inspired by the occasion, I wanted to go into it in more depth. Pause to think about this for a second. Is red, white, or blue the biggest color? In case it wasn't obvious, blue is definitely not the biggest. It takes up less than a quarter of the flag, but I'll give an example just to make sure we're on the same page. Take these long red stripes on the bottom. You can fit them neatly into these stripes on top, making a broken rectangle, which is still way longer than the blue area, so blue has less area than red. We should go over the exact specifications of the American flag. The American flag has exact dimensions, which are specified in the link in the description. Let's say the flag's height is 1, but it could realistically be anything and the proportions would stay the same. The flag is 1.9 wide and the canton, which is a rectangle containing the 50 stars, is 2/5 the width of the flag. There are 13 stripes of equal height on the flag, starting and ending on a red stripe. The canton is 7/13 the height of the flag, since there are 7 shorter stripes in the upper section. The stars are each regular 5-pointed stars. The stars' circumcircles have diameters which are 4/5 the height of a stripe. Now, you may have thought that red had more area since it has 7 stripes, but white only had 6. On the other hand, some of you might have thought that white had more area because there are 50 stars. So which does have more area? We can break down the stripe areas pretty easily since they're all just rectangles. The stripes all have heights of 1/13. The stripes in the upper portion have a width of 1.14, which is 3/5 the width of the flag, and the stripes in the lower portion have a width of 1.9. In total, the white stripes area is 0.702, and the red stripes area is 0.789. The difficult part of calculating the area is the stars. A 5-pointed star is mathematically defined as the region bounded by the diagonals of a regular pentagon. These particular stars are arranged in 9 rows, 5 of which have 6 stars and 4 of which have 5 stars. The position of the stars doesn't actually matter though, since the area is the same no matter where they are on the canton. We are given the radius of the circumcircle of the stars, but we'll call it r to substitute later. So how do we get the area? Well, the short answer is this, and the long answer is this. So let's start from the very beginning. The star can be divided into 5 congruent slices. They're all kites. And to find the area of a kite, we just need the lengths of the diagonals. One of the diagonals is just r, and the other one is the side of an inscribed regular pentagon. But how could we get that length? We set it to x. Draw this diagonal of the pentagon. In a regular pentagon, the length of a diagonal is phi times x, where phi is a golden ratio. The reason for this is that if you draw in these 2 diagonals and say the ratio between the diagonal and the side length is a, you create similar triangles from which you can get that 1 over a is a minus 1, which is solved as a equals phi. Now, since the interior angle of a regular pentagon is 108 degrees, the base angle of this triangle is 36 degrees. The base angle of this triangle is 72 degrees, so its vertex angle is also 36 degrees. Now we have another isosceles triangle, so this length is also phi times x. By symmetry, all the side lengths of the star are also phi x, so this big length is 2 phi plus 1 times x. It seems like we've hit a wall now, since we have no way of knowing what this big length is, but we actually do have a way to find it. If we go back to a regular pentagon with side length 1, we see that this isosceles triangle has lengths phi, phi, and 1. An altitude from the vertex leaves a right triangle with a hypotenuse of phi and a leg of 1/2. The altitude's length can be found with the Pythagorean theorem, and that length is very important since it gives you the sine of 72 degrees. Back in the star, we see that this circumradius makes a right triangle that is similar to the triangle of the pentagon with an angle of 72 degrees. The scale factor is r over phi, making this length r over phi times root phi squared minus a fourth. You can also find r sine 72, which will result in the same lengths. The big length is just 2 of these, so it's double that length. Now that we know the lengths of the diagonals, we can find the area of the kite. And this may look messy, but the formula simplifies roughly to 0.2245 r squared, making the area of a whole star 1.1226 r squared. With a circumradius of about 0.0308, the area of the star is roughly 0.00106. 50 stars have a combined area of 0.0531, making the total white area 0.755, which is still less than the red area of 0.789. So red has the most area of the flag by about 0.0345. Still, for those who are wondering, the blue area is 0.356, which is less than half of white or red. The percentages which are red, white, and blue are 41.5%, 39.7%, and 18.7% respectively. Once 33 more stars are added to the flag, then the white area will have taken the lead. Although if that happened, then the stars would probably be sized down to see them more, and then the US would also have to add 33 more states, which won't be for a while. Anyway, thanks for watching. Happy birthday, America, and happy semi-quincentennial.